And here, dear students, we go with higher level exercises on simplifying expressions using the associated arcs rules or ideas. Here G is sine of pi minus x minus 2 sine pi plus x plus cosine pi over 2 plus x minus 3 cosine pi over 2 minus x. Here I'm going to draw two circles to make things clear and easy. For these two, I'm going to use this circle, and for these two, I'm going to use this circle. So again, I have pi minus x. So pi is with a positive sign, so I'm going to move in the positive direction. So here, how to move? Plus pi. And then I have minus x. Where should I go? In the negative sense, or I have to complete in the positive sense? Of course, I have to go back in the negative sense. So again, I move plus pi, then I move minus x. So I am in quadrant 2. Sine pi plus x. Now I have to move pi. Let's use another color. I have to move pi, as you see here in the positive sense, plus pi and plus x, so I have to complete, and I am in quadrant 3. Now let's talk about pi over 2 plus x and pi over 2 minus x. Let's use this circle, and here is pi over 2, and here is, as you know, 0. So I have to move pi over 2 plus x. Then I have to move pi over 2 in the positive sense, as you see here, till I reach here, plus x. So I have to keep on moving in the positive sense. So again, I move pi over 2 in the positive sense, then I keep moving plus x in the positive sense. So I am in quadrant 2. Pi over 2 plus x is in quadrant 2, and finally pi over 2 minus x is also by moving plus pi over 2, but because I have minus x, then I go back in the negative direction, and don't forget, this is the positive direction and this is the negative direction, which is clockwise. So here I am in quadrant 1. So first of all, I have to move on the circle to maintain the quadrants I'm going to deal with. Now, all students, so let me erase these. Okay, and make a small circle that tells me that all students take chemistry, and this will help a lot. So in quadrant 2, sine of pi minus x is gonna be, in quadrant 2, what's the sign of sine? It is positive, so it will be positive sine x. So here I will get sine x. In quadrant 3, what's the sign of sine in quadrant 3? Only tangent is positive, so it's going to be minus 2 into minus sine x. Okay. In quadrant 2, what's the sign of cosine in quadrant 2? It is negative. But notice that I have pi over 2, and we have said that whenever we have arcs related by pi over 2 which are complementary, I have to exchange sine and cosine. So again, first of all, I maintain the quadrant. I maintain the sign of the trigonometric function I'm dealing with, which is cosine here in this quadrant. So in quadrant 2, cosine is negative, so I put the negative sign, and then I have to change cosine into sine x because I have pi over 2. So whenever I have pi over 2, I have to exchange sine, cosine, tangent, and cotangent. So I have minus sine x. minus 3 cosine pi over 2 minus x. Again, I have pi over 2 minus x and I am in quadrant 1. In quadrant 1, the sign of cosine is the same as cosine x. So in quadrant 1, all are positive, so nothing changes with signs. And I have to write sine x as well. So again, the sign of the cosine is positive. Notice that, no change in sign because I am in quadrant 1. And I keep minus 3 outside and I change then cosine into sine because I have pi over 2. And let's see it better. Here we go with what we said. Sine x minus 2 into minus sine x plus minus sine x and minus 3 sine x. And finally, we will get, after simplifying, 2 sine x minus sine x is sine x plus sine x, it's 2 sine x, and finally the answer minus 3 sine x is minus sine x. And here is another one. I have h that's equal to 5 sine 3 pi minus x dot cosine pi over 2 minus x plus 5 sine 3 pi over 6 plus x dot means multiplied by cosine 120 pi minus x. So let's see if I need to simplify things. Yes, of course. 3 pi is going to be simplified as 2 pi plus pi. All what I have to care about is just pi and pi over 2. I don't want to see 3 pi or 5 pi over 2, for example. I have to simplify them. So I simplify 3 pi as an even number plus a pi. Okay, or I can put it like 4 pi minus pi. Both will give the same answer. Now pi over 2 minus x needs no simplification here. We don't have to decompose anything. 3 pi over 6, if we simplify by 3, we are going to get pi over 2 plus x dot cosine 120 pi is going to be cancelled, and then what remains is just minus x. So I have, let's see, I have 5 sine 2 pi plus pi minus x dot sine x because cosine pi over 2 minus x is in quadrant 1. In quadrant 1, cosine is positive and it's going to be changed into sine x. In quadrant 2, sine of pi over 2 plus x is in quadrant 2. The sign of the sign in quadrant 2 is positive because you know that all students take chemistry, and thus sine of pi over 2 plus x is going to be cosine x because we are in quadrant 2 and the sign of the sign is positive, and it's changed because we have pi over 2. Now cosine of 120, as you see, is cancelled, then we still have cosine of minus x. So we are going to cancel 2 pi. We still have pi minus x. Where's pi minus x moving on this circle? Pi minus x. So we are in quadrant 2 where sine is positive. So here sine is positive. Dot sine x plus 5, this will be changed into cosine x, and this will be kept cosine x because minus x is in quadrant 4 and it is positive. So let's erase these and continue. So as I told you, we are going to get sine x positive multiplied by 5 dot sine x plus 5 also cosine x and positive multiplied by 5 dot cosine x. Now what do we get here? We get 5 sine squared x plus cosine squared x. Then taking 5 common, as you see, sine times sine is sine squared, cosine times cosine is cosine squared, as if we get 5 sine squared plus 5 cosine squared, and taking 5 common, what is this? Remember, it is 1. It's the most famous trigonometric rule. And finally the answer is 5 into 1, which is 5. And finally, here are like a collection of all the rules related to the associated arcs. Some students prefer to memorize these rules, and some students prefer to use the circle as I keep showing you, and to me, I prefer to use the circle. I don't prefer to memorize rules. I prefer to let you know how to discover the signs, how to discover the simplified form without memorizing any rules. And here we go with the last examples with higher level expressions. I equals tangent 121 pi plus x minus tangent 14 pi plus x, etc. We are going to simplify again. Let's first of all start decomposing the numbers. 121 pi is written as 120 pi plus pi. 14 pi is even, it's going to be cancelled. 5 pi over 2. Now how to decompose 5 pi over 2? 5 pi over 2 can be written in two ways. It can be written as 4 pi over 2 plus pi over 2, or it can be written as 6 pi over 2 minus pi over 2. Now if you remember when we talked about the principal value in case of radians and pi and so on, we aim to choose those who give us even numbers. For example, here 4 pi over 2 gives 2 pi, and I usually care about those giving even numbers, while 6 pi over 2 gives 3 pi, and I don't care about those giving odd numbers. So this possibility is cancelled, and I have to choose to write 5 pi over 2 as 4 pi over 2 plus pi over 2. So we decompose 5 pi over 2 to 4 pi over 2, which is gonna be cancelled because it gives an even number multiplied by pi, and what remains is just pi over 2. So we have here 4 pi over 2 plus pi over 2, and as I told you, this will be cancelled because it gives an even number. 4 divided by 2 is 2 pi, and 2 pi is equivalent to 0. Any even number multiplied by pi is as 0. Now cotangent minus x is kept. We don't have to decompose anything. Now let's continue and see what's going to happen. We have tangent 120 pi plus x, as you see. 120 pi plus pi, we cancel this. What remains is just pi plus x. So pi plus x. Here what remains is minus tangent x only. What remains here is tangent of pi over 2 minus x and minus 3 cotangent minus x. And now let's use the help of this circle. And let's use colors. Pi plus x is like moving that way. Pi plus x, so I am in quadrant 3, and that's why tangent is positive. We finished this. Minus tangent x is kept. We finished this. Now, by decomposing, we get pi over 2 minus x. Now, where is pi over 2 minus x? Let's move on this circle. Pi over 2 minus x is like moving that way. Pi over 2 minus x in the negative sense again and again. Here is the positive sense, and here is the negative sense. So I move pi over 2 minus x. So I am in quadrant 1. So this is in quadrant 1. And finally, cotangent of minus x is in quadrant 4. That's why we get minus cotangent x, all sine, tangent, and only the cosine. So the cotangent is like the tangent here in quadrant 4. It is negative cotangent x. And now let's see what's going to happen and the final answer. So tangent x minus tangent x, as you remember here, it's in quadrant 1, then it's going to be tangent pi over 2 minus x, and it's going to be changed into cotangent x, because whenever we have pi over 2 we exchange sine and cosine, and we exchange tangent and cotangent, and minus into minus gives plus 3, then I will get tangent x minus tangent x plus cotangent x plus 3 cotangent x. Making calculations, cancelling these two together, we will get 4 cotangent x. And here is the last example. I have j equals 7 pi over 2 minus x dot cosine 24 pi over 2 plus cosine 3 pi plus 6x over 6 dot means multiplied by sine 120 pi plus x. So let's see how we are decomposing. 7 pi over 2 minus x is decomposed as follows. Why? Let's see why. 7 pi over 2 can be decomposed in two ways. I can write it either 6 pi over 2 plus pi over 2, or I can write it also 8 pi over 2 minus pi over 2. That's how to get, both will give me 7 pi over 2. Now, why did I choose that one? Because 6 pi over 2 gives 3 pi. If we divide 6 by 2, we will get 3, and we don't care about odds, we care about evens. So that's why we have to choose this one. So to decompose 7 pi over 2, I take 8 pi over 2 minus pi over 2. This will give an even number, which is 4 pi. So what remains is minus pi over 2 minus x. Now 24 pi over 2 is definitely 12 pi, and it's going to be cancelled because it's even. 3 pi plus 6 over 6 is as dividing 3 by 6 and 6 by 6. So we will get pi over 2 plus x. So dividing 3 by 6 and 6 by 6 will give pi over 2 plus x, and 120 is even, so it's going to be cancelled. Now let's erase and continue. Now I have minus pi over 2 minus x only. I have minus x only, pi over 2 plus x, and sine x. And let's use the help of the circle to know where did these come from. And here we go to use the circle. Don't forget, all students take chemistry. Here is the positive sense, and here is moving in the negative sense. Let's start. How to move minus pi over 2 minus x? Let's see. We have to move minus pi over 2 minus x. How to move that way? Here is 0. How to move minus pi over 2? Let's think a little bit. Should we move like this or like this? Of course, we should move like this. So this is how to move minus pi over 2. I have minus x beside it, so I keep on moving in the negative sense. So I am in quadrant 3. So here we are in quadrant 3. Okay? In quadrant 3, only the tangent is positive. So cosine and sine are negatives. Now to get the sine, I look at this given function. What is the sign of sine in quadrant 3? It is negative. So again and again, the sign here, minus or plus, goes for the given trigonometric function you see here, which is sine. Okay? And because you have pi over 2, or I have pi over 2, I change it into cosine. So again, and for the last time, I say that the sign plus or minus refers to the given function I'm simplifying, which is sine. Because I have pi over 2, I change it into cosine. Now cosine of minus x, we are in quadrant 4, as you know. Minus x is here, then definitely it is plus cosine x. So we are multiplying now minus cosine x by cosine x. Pi over 2 plus x is like moving that way. Pi over 2 and the plus x, then I am in quadrant 2. So in quadrant 2, what is the sign of cosine? It is negative. So as I told you, the sign plus or minus refers to the given trigonometric function, which is here cosine. So because in quadrant 2 cosine is negative, then we put minus. And because we have pi over 2, we change it into sine x. And finally we have dot sine x. So the final answer will be minus cosine dot cosine plus minus sine dot sine, which is minus cosine squared minus sine squared, taking minus as a common sign, so we get minus into cosine squared plus sine squared, which is minus 1. Of course, dear students, we are going to make more and more training exercises concerning these ideas, concerning the identities, concerning the remarkable angles, choosing the angles, and so on later, inshallah. Now, hope you are now satisfied with our trigonometry chapter. Hope you are now self-confident with doing such examples. Hope you are going to review them more and more and more in order to be so smart in solving expressions, including trigonometric functions and remarkable angles. Thank you for watching. Hope you are still fine all the time.